Kia ora Year 12. This is the last question from the Stats 2 paper in the May 2018 A-level exam. I'm going to split this into two parts because it's worth 12 marks and it goes on for quite a while. It's all about the Poisson distribution. So we start off with a couple of probability questions and then we have some hypothesis testing. So if you just pause and read through the question, make sure that you note that we're talking about a Poisson distribution with lambda given per day. And for the girls, lambda is going to equal 0.2. And for the boys' absences, lambda is going to equal 0.3. So we know with a Poisson that we can add those two distributions together. It's a really nice feature of the Poisson distribution. And I'm pretty sure we did the proof of that in class. But all you have to know now is that the total absences will have a mean of 0.5. So lambda is going to be 0.5 per day. But we're interested in a 2-day period, so lambda will be 2 times that, which is just 1, and that's going to make our calculations pretty easy. Find the probability that the total number of absences is less than 3. So remember, we're working with a discrete distribution, so that means that we have 0, 1, or 2 days of absence. Now you can do this using the recurrence relation, but because lambda is 1, it's really fast just to use the formula. I haven't even bothered to do a little table. So that's what my probability is going to be. And when you work that through, you can collect up some like terms. First, we've got 1 e to the negative 1 here, another one here, and a half here. So that gives me 0.920 to 3 significant figures. Okay, on to the next one. Find the probability, oops, I don't know why that's there, that during a randomly chosen 5-day period, the number of absences by boys is more than 3. So we're back to working with a lambda of 0.3 per day. So for 5 days, that means lambda is going to be 1.5 per 5 days. Probability that x is greater than 3 is equal to 1 minus the probability of 0, 1, 2, or 3. I'm going to pause the video here and just put that calculation in. Remember, a nice way for you to do your working out is to use a little table like this. So you can do that and fill in those numbers. Actually, I'm just going to skip that step here, guys, so that we get through a bit faster. And so that works out to be 1 minus 0.934357, and I got 0.0656 again to 3 significant figures. Now just watch out here that this leading 0 is not one of your significant figures, so you don't want to round that to 0.066. Alright, so that's all I'm going to do in this video to keep it really nice and short. I'll be back in a few minutes with part 3, which is going to be some hypothesis testing.